Okay, good morning. How it works. How does the zeAC work? Well, the zeAC does both cooling and heating, and it does this in different ways. But the most important, the primary way, is evaporation and condensation. Have a look at this. Okay. Now, this is the material, the cooling and heating material, composite. And on the surface of this material are microporous. This material is a microporous surface, or a microporous material, and the surface of it has micro projections, nanoscopic projections that increase the available surface area exponentially. I'm talking thousands of times more than the actual surface of this object, because of the nature of the material. Now, what that means is that water, even in a humid environment, still gets to evaporate, albeit at a slower rate. Now, because the water has a lot of surfaces to evaporate from, as it evaporates, it releases the heat of evaporation, the latent heat of evaporation, and that causes cooling. Now, how does it cause cooling? It absorbs that heat from the material and the whatever shape the material is made of and whatever mass the material has. Heat is absorbed from it, but heat is also absorbed from the environment. Heat that is absorbed is heat that no longer exists in the environment, so the environment ends up cooler. Similarly, when the air is moist and humid, like when it's cold, the vapor in the air condenses on these surfaces that we also evaporated from, and condensation does the opposite of evaporation. Condensation releases heat into the environment instead of absorbing heat into the environment. So all day long, this thing is condensing and evaporating moisture, causing both cooling and heating. Now, the temperature that we get is really the balance, the equilibrium between the heating and cooling that this thing is doing. All right? Now, it's not deliberately heating, it's condensing. So let's say the condensing and evaporation that this thing is doing. All right? The difference between how much it is condensing or how much it is evaporating results in the temperature that you get. So in the winter, when it will do more condensation than evaporation, you're going to get heating. So it will stabilize the room temperature by releasing heat through condensation. And in the summer, right, it will stabilize the room temperature by absorbing heat from the environment as it evaporates water. Now, this is the basic way that it works. Now, as the heat that it absorbs from the body of the material, or something like this aluminum plate that I have put this thing in right now, that heat also exchanges heat with the environment. So the heat that is stored in the mass, or that is transferred to a conductor like this aluminum plate, gets transferred into the air. Then secondly, additionally, because of the temperature of the mass and because of the low vapor pressure of the material, all the air in the surrounding area is headed in one direction, which is in the direction of this cooler material. Of course, you know that heat moves from a place of high pressure to a place of low pressure, right? A place of high temperature to a place of low temperature. So this is a place of low temperature and a place of low pressure. So all the heat in the building, right, or in this area is moving in its direction, right? All the vapor is moving in this direction. Now, what does that do? That causes some, subtle wind, because that's movement. What is coming here is leaving here and coming back again, or other things are coming after it. So it creates movement in the interior environment, that when, it's very hot, you can actually feel, the, the explosions of vapor, or kind of the movement of that air cool air coming towards you, even though there is no fan in the room. So that circulation of air, all right, over something that is cold also results in the cooling of the environment. Now, as a black body, you can see, right, black things absorb heat, right? They also radiate heat. So that property is resulting in another way of cooling, which is absorbing the heat in the environment. So these different things that are going on regulate how the temperature and the humidity in the room end up. And given my observations and experience with this thing, it really gives you the best possible outcome, a comfortable feeling that is not too cold, not too hot, just perfect. And the more of it you have, the higher the cooling capacity, the higher the dehumidification capacity. Now, there is another component of this, which is the plant. Okay. So what the plants do